Hello everyone. Today we will be seeing the first PBL review of our project, which is the automatic door opening system using motion sense. This is the basic block diagram of our project. We will be using a PIR sensor to sense the motion, a hex keypad for the security system, the microcontroller which controls the whole system, and the servo motor which controls the door. Now let us see on how this project works. Firstly, it checks whether the door is unlocked or not. If it is locked, it uses the polling mechanism to keep checking if the door is locked or not. Once it senses that the door has been unlocked, it checks for any motion. If no motion is detected, it keeps on. There is another polling mechanism which keeps checking if somebody has arrived. Once somebody arrives, it opens the door and starts to check again if somebody is still there. If somebody is still there, it keeps waiting until and unless the motion has stopped. Once the motion stops, the door has been closed and it goes back to the initial system, checking whether the door has been unlocked or not. This is the HC-SR501 PIR motion detector. Now this works on infrared technology and it is especially used for battery powered automatic control products. Now I will come to the specifications. The operating voltage for this is between 5 volts to 20 volts. The power consumption is about 65 milliwatts. The transistor to transistor logic output compatibility ranges from about 3.3 volts, from 0 volts to 3.3 volts, and the delay time is adjustable. And there are two trigger methods for this motion detector. One is the repeated trigger method, and the next one is the non-repeated trigger method. Now we are using the repeatable trigger method because if there is a human activity in the sensing range, the output will remain high as long as the human activity continues. But once the human activity is over, after giving some delay, the output will be set to low. Temperature range for the operation is from -15 to +70 degrees Celsius, and the sensing range is about 7 meters, and the angle is less than the angle should be less than 120 degrees.
Okay, now we are going to see about the 4x4 hex pad. As you can see here, we have about 16 buttons, and the numerals and the alphabets have been engraved upon that. However, these don't hold much sense since they can be programmed to whatever the user whatever the programmer wants to display on them. Okay, so it consists of 4 rows and 4 columns, and basically it works on the principle of these transistors as we see here. When a button is pressed, for example this is pressed, then this contact gets established between R1 and C2. So it can be interfaced to our microcontroller using the logic that initially all the columns need to be set to 1 and all the rows need to be set to 0. For example, we press this key number 5. This is known to us, however we need to make this understand to the microcontroller. So as soon as the key 5 is pressed, the connection between R2 and C2 gets established, and since R2 is 0, the C2 gets set to 0. But in order to identify this with the help of the program, initially we set all the rows to 1. As soon as we do this, C2 goes to 1. Now in order to check which button was pressed, we individually keep on setting the rows from 1 to 0 in order to identify which column which row and which column has been pressed. That's how the keypad works.
This is the servo motor that we'll be using in our project. Servo motors are basically electrical motors that work on servo mechanism. So in servo motors we can control the angle of rotation. We will be using servo motor in our project to control the movement of the door, and we will be using Tower Pro's SG90 servo motor. Torque of this motor is 1 kg per centimeter, and it has a wide temperature range from -30 degrees Celsius to +60 degrees Celsius.
Okay, the limitations of a project is that, for example, in the PIR sensor there is a specific temperature range that is from -15 degrees Celsius to 70 degrees Celsius. Beyond this range, the PIR operation is faulty and it does not give a correct reading or output. The problem with the hex pad is that often the output or the buttons we press do not get latched, so we need to press them repeatedly and again in order for the number or the input to get latched. The problem is known as debouncing, and there is probably no solution to that, and we need that depends and varies from hardware to hardware. For real-time applications, we need to purchase or utilize the use of a more expensive servo motor to move larger doors.
This is the estimated timeline of our project that we will be following for the completion of the project. By mid-March, we will be completing all the programming and software implementation, and the hardware implementation shall be completed by mid of April. Thank you.